How can we do it? I think it's pretty easy. Well, let's go. Assume play fair. And now we're going to try to prove Euclid. Okay, so let's take, once again starting at this point, and we will have some big lines like this. Let this be line L and line M. Let this be, I guess I'll call this angle 1 or something. Yeah. And I'll call this angle 2. And so what I know is that angle 1 plus angle 2 is less than 180. Okay. What can I do with this fact? Somehow I have to show that L, so I'll just even write that. So given 1 and 2 add up to less than 180, and what I need to show to complete Euclid is that L intersects M. So, or L is not parallel to M. Okay, well, obviously we are going to do this by contradiction. So suppose that L is parallel to M, and if that leads to a contradiction, then we will know that they are not parallel, and that's what Euclid proves after all. Okay, good. Well, if 1 plus 2 is less than 180, then that means that, what is this? Yeah, if 1 plus 2 is less than 180, then it means that there is some other amount by which they differ from 180. So, okay, we don't maybe really need to do that. We can just go right in. So call this point A. Let me just be casual. Call this point A, call this point B. What I would like to do now is to just copy this angle 1 up here. In other words, if 1 and 2 don't add up to 180, let's find the angle that does. And so I'm going to draw this new line, calling it N, suspiciously parallel to L, and I'm going to do it in such a way that I copied, well, I just copied angle 1, right? So copy angle 1 and construct angle 3 at B such that angle 1 equals angle 3. I think this is what I want to do. Call that line N. Call the line N. Why is that so great? Well, there is this little angle here. Let's call it like 4 or something, this little angle. And okay, our eyes don't deceive us here, right? Because, what do I want to say now? Well, why is it so hard? 3, oh, I didn't call that 4. I called this whole thing 4. Okay, let me call this whole thing 4. And let me call this little angle here 5. All right, and now it seems like I'm just kind of looking at the picture and making all kinds of wild claims, but I'm not. Angle 3 I copied. I just copied angle 1, so that's totally legit. 4 is just the supplement of angle 3. Yeah. So what I know is that angle 3 plus angle 4 is 180. But also I know that since 1 equals 3, then I know that angle 1 plus angle 4 is 180. I think that's what I wanted. And I also know that angle 1 plus angle 2 is less than 180. And if that is the case, then what do I want to say? So that means that angle 1 plus angle 2 is less than angle 1 plus angle 4. In other words, angle 2 is less than angle 4. Okay, this seems like a bunch of writing down obvious things, but what it means is my picture can be trusted. I'm actually like invoking the fact that I know that 1 and 2 add up to less than 180. So therefore, the supplement of angle 1, angle 4, has to be greater than angle 2. So therefore, this little angle 5 is like a real thing. The measure of angle 5 is actually like positive. Well, okay, what's the whole big idea of this? The whole big idea of this is that my assumption that I made over here, that L is parallel to M, which I guess I should mark, that was the assumption which was supposed to lead to contradiction, will in fact lead to a contradiction now, because we know by converse corresponding, since angle 1 equals angle 3, converse corresponding says that L is parallel to N. L is parallel to N. And this just cannot be that L is parallel to N because L and N both go through B. And so what we have here is the fact that since angle 5 is positive, that's my way of justifying that in fact line M, which is this one, and line N are not the same. M is not N. And now we have some bad times, because L is parallel to M by the assumption of this proof by contradiction. L is parallel to N by converse corresponding. These are sort of separate remarks. And also M is not equal to N. That is a contradiction with Playfair. This is a contradiction with Playfair. This is exactly what Playfair says can't happen, that there are two lines through B parallel to L. And so indeed this whole thing has led to a contradiction, which means that L and M are not parallel. I'll write that down, maybe down here or something. Cha-cha. So L is not parallel to M, which means that they must intersect somewhere, and that's exactly what Euclid says. Okay, that was way too much detail, way too slow. I kind of feel like anyone in my class watching this already knew all this stuff anyway, but I hope that helps someone. And this will definitely be on the test. Goodbye.